Good evening to Europe, good afternoon to Boston, and good morning to the West Coast, members, friends, and guests of the German-American Business Council of Boston. I am Susan Glovsky, principal at Hamilton Brooks Smith Reynolds law firm in Boston, and I'm a member of the board of directors of the German-American Business Council. On behalf of the GABC, a warm welcome to all of our guests joining from the virtual to this virtual event from Boston and around the world. I would like to extend a special welcome to members of the German-American Business Association of California. The association is an important partner with us on this event. This is the third in our series of virtual panel of discussions of smart cities. Smart cities is the topic of GABC's German-American Economic Forum, a forum gone virtual as a result of the pandemic, which has allowed us to gather so many of you on my computer screen. Stay tuned as additional virtual, in-person, and hybrid events directed to topics that would have been part of the one-day forum may pop up during the year, hopefully more in-person than virtual, and we will see. This is the point where, as a speaker, I had many years ago always felt I needed a joke. If any of you can come up with one, please send it to me because I haven't thought of one except to say 2020. Hopefully 2021 will be much better. For today's discussion, we brought together an excellent group of speakers who will look at the topic of energy efficiency in the built environment. You will learn about the topic from multiple and varied angles, including technologies that help track energy flows and carbon emission occurrences in the planning and construction process, smart tools to collect, measure, and steer energy flows for high efficiency in finished buildings, necessary stakeholders to realize energy efficient and low carbon buildings. As a brief introduction of our speakers, Kent Larson is director of the City Science Research Group of the MIT Media Lab. Before joining MIT full-time in 2000, Kent practiced architecture for 15 years in New York City. Kent's research focuses on developing urban interventions that enable more entrepreneurial, livable, high-performance urban districts. Ben Thompson is Director of Sustainable Business at Autodesk and Head of Employee Impact for the Autodesk Foundation. Ben leads the team to incubate technology and market opportunities to help Autodesk's customers win business and save money with sustainability. Ben is based in the Bay Area. Andrew Krennig is Solution Director for Smart Buildings and Pre-Construction for Siemens Smart Infrastructure, where he is responsible for developing digital smart buildings, integrated solutions across the United States, the Northeast. Andrew has 15 years of experience in controls, automation, technology, integration, and systems related to building operation and control. Please put your questions in the chat. They will be addressed as we move along. And before I turn your screen over to Kent, the German-American Business Council would like to thank Siemens. Siemens is our lead sponsor for this German-American Economic Forum, now turned series for the moment, and our upcoming forum, whether that be virtual, hybrid, or in person. Thank you, Siemens. And I now ask Kent, please take the screen. And
okay, let me share my screen here. And can someone confirm that that is working properly? Okay, well, it's a great pleasure to be with you today. I'm going to take kind of a high-level view of this topic from the perspective of communities. Specifically, I want to talk about resilient communities for post-pandemic cities. And one thing to start with that I think we need to realize is crises typically accelerate the adoption of innovation, and this is clearly true with cities. I mean, there are a whole series of crises, starting with the London fire of 1666 that led to fireproof buildings, fire hydrants, the insurance industry. The London cholera outbreak of 1854 led to modern sewage systems, the field of epidemiology, and you can go on and on. We are now in the middle of the pandemic of 2020, and it has led to depression scale unemployment, particularly in the US, revealed tremendous inequities. A lot of the infrastructure that we took for granted has failed. Supply chain, shopping centers are closed, healthcare systems are stressed, transit is unsafe, our homes don't work for many of the new activities that have entered the home, and global warming will inevitably create a whole series of additional shocks when we get through the pandemic. So we need to take advantage of this crisis to improve the societal conditions. And I think the grand challenges of our era, public health, equity, global warming, are best addressed in cities. And I believe that successful cities in the future will be a network of resilient communities. So we've been working towards a data-driven, evidence-based process for creating more resilient communities. And we have a number of components to this process. We start with insight, which is really just understanding the social, environmental, and economic conditions. And we do this in many different ways. We analyze telecom data. For example, this is a project in Andorra where we're now correlating this to COVID-19 infection serology data, and we can reveals complex patterns in the city. We can also do this at the scale of a building or an apartment. These are sensors that we have deployed, in this case in an apartment in Malmö, Sweden with IKEA, where the bouncing ball shows the sequence of sensor activations, in this case as when somebody prepares a meal. We can bring this and many other data sets together to measure the urban performance of a community. This reveals Kendall Square and how poorly it actually functions as a community, looking at the different types of density, diversity, proximity of the elements, and embodied and in use energy for both mobility and buildings. With that, then we can design the interventions to improve on those conditions. And in my group, we've looked at these systems: urban housing, urban mobility, urban programming, distributed energy, distributed food production, etc. I'm just going to take a minute, since I only have a few minutes, just to talk about two of those. So equitable, affordable urban housing. Some years ago, we built a prototype of what we call the MIT City Home, which was a 200 square foot apartment, a 19 square meter apartment that functioned as if it was 3 times bigger in terms of the functionality. So we have a fully functional office, a dining room for 6 people, a living room for 6, a tiny bathroom that dynamically opens up to give access to a shower and washer dryer, handicap access. We've now taken this further, where we're trying to develop a complete building system for a new model for housing, starting with cross-laminated timber panels that form spaces that then can be fit out with prefabricated modules with integrated technology. Here you see small, medium, large, extra large apartment possibilities, but the small apartments are the most interesting. So this is taking our 300 square foot apartment, what's that, 28 meters or so, and looking at how it could dynamically be dynamically reconfigured from living to sleeping to working to guest room, micro kitchens, prefabricated bathrooms. Now, people thought we were kind of crazy to think about these architectural robotics for buildings, but we spun off a company a few years ago, Alphabet. Google and IKEA have provided our funding, and that bed that I showed in the rendering will soon be commercialized, offered as a product to real estate developers, and IKEA will start selling some of our systems in their retail stores later this year. So this is a living space that dynamically converts to a socializing space. We're also working on lightweight autonomous mobility. So we did cars some years ago, but we decided that the city needed much lighter weight autonomous modes, something between shared bikes and ride share. We call it a persuasive electric vehicle. It's a bike-like autonomous vehicle that operates in the city like a social robot, tries to be a good citizen. You see these two young women are not freaked out by the vehicle. We built a whole series of prototypes that we may decide to commercialize. Here you call for it like you would an Uber, any rideshare vehicle, drive it under human power to your destination. When you get to your destination, you can release it to pick up the next passenger autonomously, or in this case, carry packages behind. And last year we prototyped an even lighter mode. It's a bicycle that can be ridden like a conventional bicycle, but it converts to a three-wheel autonomous vehicle that functions again like something between a shared bike and a rideshare system. So that's insight, and then the transformation, the interventions that could improve those conditions. But now we need to focus on the prediction models, modeling and simulation to estimate the impact. So we did a thought experiment using the MIT transportation survey that delineates where people live, where they work on campus, the mobility modes, and on average, people can generate about 3 tons of carbon. Now, if we converted to all electric vehicles, it goes to 2.19 tons of carbon per person, not bad. But if we actually could enable everyone who worked at MIT to live at MIT, it's 0.5 tons, a 6-fold increase in mobility energy performance. And if you brought to bear all of these innovations and many more at the scale of a community, that over time, the urban metrics would dramatically improve. And we look at the environmental performance, particularly CO2 generation, the social performance, which is innovation potential, health and wellness, et cetera. And I don't think we can think about environmental performance separate from social and economic performance. Okay, so we've done insight, transformation, prediction, but we still need consensus. We need to bring together all the stakeholders. And for that goal, we build these interactive urban scale, community scale simulation platforms. Here, see the radar plot is updating in real time. You change land use density dynamically. A 3-dimensional rendering shows the relative scale of the elements. Or a project we did in Hangzhou in China, where using a tablet, one can dynamically configure land use, mobility systems, density, et cetera. We can have layers and layers of heat maps. So in this case, red is bad, green is good. This is walkable access to parks, where you replace a building element with a park element, and there can be layers and layers of these simulations, walkable access to healthcare or jobs or transit, et cetera. Or we could map our micro units or any other type of housing to these elements, and you're moving the numbers of people and their demographic profiles, which can then update the simulation engines. And we've deployed these systems. I show this in Germany, because this was in Hamburg, project to help identify sites to build housing for the refugees that we deployed a few years ago at the height of the refugee crisis in Hamburg. An article in the Atlantic magazine, Germany's radical pro-refugee urban planning experiment, about our project, and a related one in Berlin. But this really was not urban planning experiment, it was a consensus building experiment. So I believe that we should aspire to a 10x increase in the environmental, social, and economic performance of communities by 2030. And I don't think there's any reason why we can't get there if we commit the resources to it. But it will take innovation in design, technology, and public policy. Okay, so that's a quick overview of what we're thinking about. And I would like to now bring on Andrew Krenning, who is the Solution Director of Siemens Smart Infrastructure.
Great. Can everybody hear me all right? Perfect. All right. So I'll share my screen here. So hi, everybody. My name's Andrew Krenning. As mentioned, Solutions Director for Siemens Smart Infrastructure, focusing in on the smart building, smart campus, kind of smart city discussion and environment. So just a real quick introduction into who Siemens Smart Infrastructure is. So you kind of see here on this diagram what we've done with this collection of the organization and the way that it's been structured. What we're really doing and what we're trying to do is enable a lot from the building perspective, the infrastructure, across the various industries. You kind of see here all the various types of buildings and types of industries, right, from the industrial side, in bridging and helping to bridge that gap and connectivity to the grid, and how that's going to evolve, you know, today, tomorrow, into the future. Siemens Smart Infrastructure is organized and collected in a way that really supports our customers of today, as well as the customers of tomorrow. So just a real quick, you know, kind of a different diagrammatical view of it. You know, we really see smart buildings as a key element of the smart city of the future, right? So if you kind of look at this diagram, we've got smart buildings, right? Can be smart hospitals, smart living, smart commercial buildings. There are key elements to that it needs to start to communicate to really kind of create these microgrids or these micro communities. It can be energy storage, distributed energy systems, e-mobility infrastructure, right? Because as we look at a lot of these technologies, even as what Kent just showed, a lot of that is electrification, right? Where is that electrification coming from? And how are we sharing this information and data across not just buildings, but across this area? So just a quick kind of introduction. We'll certainly talk about this more during the panel discussion today. We really see the idea of smart buildings as a journey. It's not like you leave your building that you work in every day, one day, and you show up the next day and it's a smart building. It's a journey. And it's a journey that we like to collaborate and work with partners and work with our customers to help bring and bring to market. So you kind of look at the traditional building, you know, very siloed, unconnected, preventative maintenance. Everything was done on site in a very, very old fashioned way. You know, there's integrated buildings where you start to tie together data and information to the building, but there's really no business intelligence. There's really no connectivity really between systems that really implement anything of value. Next is smart buildings. That's where the industry really is today. We're talking about IoT applications, real-time data analytics, and being able to change what's going on inside of the building real time to change the impact and the influence of what's going on. And then as we move into the future, really the idea of a future of the smart building is kind of some of the things that was just kind of mentioned, this idea of simulation and artificial intelligence, and this idea of a building twin, which I think we'll get into a little bit today as part of the discussion, and prescriptive or preventative maintenance. Wouldn't it be great if we knew when something was about to break and plan for it and properly plan for it versus, you know, waiting until something breaks? It would be great to know and be able to have foresight into some of those things. we get a lot of questions, or I get a lot of questions on, why? What is driving smart buildings, smart communities, smart campuses? And there's a lot of different factors. I would argue, so these numbers are pre-COVID and pre-pandemic, but I would argue that the health and wellness and everything will be, as we come out of this and more data and research comes, as we come back to work and go back to the new normal, the health and wellness aspect is going to be a huge element of the smart building, and is a big element. But you kind of see here some key numbers and key statistics specifically to discussion today. Obviously, we'll focus on that idea of on average 30% of the energy used in buildings is inefficiently or unnecessarily consumed, which is something that I think we'll get into the discussion today and talk about it. So really looking forward to it, and thank you for having me. So Ben, why don't you take it from there?
Sure, thanks so much, and thanks all for hosting us here. This is going to be a great conversation. So my name is Ben Thompson, and I lead our sustainable business strategy at Autodesk, and really that's about trying to understand the goals of our customers and making sure that we can deliver the right solutions to help them design and make everything on the planet. So we make software solutions that help people design, make, and operate, and hopefully redesign, remake, and reoperate products, buildings, infrastructure, and even entertainment. And I would just +1 everything that both Andrew and Kent said when it comes to the importance of data to create insights, to then power decisions that then improve performance. And I think that's really important. And I'm going to not share any slides, so you can look at all our smiling faces. But I think that's really important when you think about buildings and infrastructure in the context of their spaces that they're in, and the context over time that they operate in. And especially thinking about the life cycle of a building and how there's actually a convergence happening between those different phases, from design to construct to operate and then start over. And similarly with the convergence of the contexts that a building operates within. Kent showed some great examples about, light, making transportation more efficient. All these things connect at the end of the day. And, as a technology provider, bringing the data about all of those different contexts into a central place for decision makers to be able to approach it differently is very, very important. But more importantly, translating those data sets into insights. The spider charts that you showed, those radars, Kent, were really, really great, because there's so much complexity inherent in the built environment, and the human brain just can't keep that all together. And so we need technologies that can simplify it for us, that can bring stakeholders together to collaborate on this information and find new insights, or even rely on the technology to combine the data in ways that maybe were not as intuitive for us and help us make even better decisions that we couldn't before. So that's really important at each phase of the building life cycle. Some research shows that up to 80% of a project's environmental impacts are determined early in that design phase. And then in construction, when you're building or retrofitting a building, some data has shown that about 50% of the world's solid waste comes from the construction site. That's wasted money, but that's wasted materials, wasted emissions. Like, we can do way better. And then, of course, as all that value is created in design and make, that needs to be handed off to when a lot of the emissions happen during operations. Every 7 years, you start to see that performance creep, and you start to lose the intent from that original design. So you need to be sure that you understand, the owner understands that intent throughout their operations, and finds ways to, I guess, commission and keep the building going before things break, before things get so bad that you're starting to think about decommissioning. Because the best building is one that can be more resilient over time and change to the needs of its occupants, rather than having to, at worst, tear it down, or at best, salvage the materials inside of it and reuse them. So eager to talk about all of those phases and how technology can bring together stakeholders to realize more examples there, and maybe even uncover some of the unexpected areas of impact within that life cycle that we can talk about.
Well, great. It's a pleasure to be with both of you today, and so I'd like to start out by asking both of you a question. So, you know, and that is basically, what does smart mean to you? You know, the classic definition of smart involves IoT systems like sensors and algorithms to optimize the performance of systems like buildings. But what is your definition of smart? Because it's been evolving over the last few years and has kind of become a marketing term as much of anything, you know, within companies.
Sure, Ben, I can take that first. So from my perspective, really smart, like you mentioned, right, means a lot of different things, and it means a lot of different things to a lot of people. What I like to do is boil it down to a couple of key elements. First is you mentioned kind of IoT, sensors, and infrastructure. There's a value to all of that as it relates to the building operation and sustainability and all the things that we're used to, let's say, in the built environment. There's a key element to smart that has evolved, and I would say over the last 10 months has exponentially become more and more important, and that's the people-centric element to this, the health and wellness. And what we've noticed is if we provide this data and information and we allow the building occupant to start to interact with their environment and have influence over their environment, not only are they happier, more productive, more willing to stay at work and work harder and work more efficiently, they actually improve the performance of the building. They actually will say, well, geez, it doesn't need to be 72 degrees in the winter. It can actually be 70 degrees. I'm fine functioning at that temperature. So really, when we see kind of these two elements combined, obviously there's all the elements of what Ben talked about, the intelligence and the data, absolutely. But what I like to boil it down to is those two simple elements. You put those two pieces together and implement technologies that impact both of those, that's where you really get the intelligence and the smartness you need to run the built environment.
Yeah, absolutely. Ben?
Yeah, I think that's great. And I love the slide that you shared, Andrew. And I get really excited about that rightmost opportunity for the future. And putting people at the center of that is such a huge opportunity. And I would say that, yes, and not only being able to respond to what those occupants need, but also being able to predict what they're going to need as their needs change, and learning from the operation of the building and learning from those users and being able to adapt. I think when we talk about resilience in this space, especially in an infrastructure context, we often talk about like hardening and being strong and being able to absorb any shocks to the system. But really, I think it's more about adaptability and being able to flex with those different shocks and needs and being able to anticipate them so that the effect of those shocks can be mitigated and, you know, some of the value can be maximized.
Bend, not break.
Exactly.
Yeah. Well, so I'm really pleased both of you mentioned the human aspect of it, because a few years ago, when with discussions of smart systems, that was hardly ever mentioned. So it brings me to this next question about data. All three of us have talked about data. So what data do you wish you had access to but do not?
You want to take that first? Yeah.
Sure. I mean, so
either one of you.
yeah. So first off, I'll just say I think part of the magic of these solutions isn't prescription about what data needs to be there to make it operate. Sure, there are things that come out of the box in any of these solutions that you look at from any provider where it'll help you measure the energy or it'll help you understand, you know, the maintenance requirements, and from that you need data about all the machinery and who to call before it breaks. it's part of the extensibility there that's inherent to some of these smart solutions that lets really the building operator bring the data that's most important to them and then try to derive some of the insights from that. And some of the creativity I've seen from our customers has been pretty amazing, because I've seen things like understanding the paths that people walk through in a building so that then you can adapt the program of the space to better accommodate the users there. Like that is not a workflow that I originally designed and have been pushing on the market. It was something the market created and adapted the tools to use it for. So I think there are a lot of capabilities like that. I think COVID especially has Kent, some of the examples that you showed with those smart sensors, and I've even seen computer vision be applied there to understand like what surfaces are being touched a lot, so that we can send work orders to the building staff to go clean those surfaces, or maybe even change them so that they're not being touched as much. So I apologize to not identify like what is missing, because it's kind of an open canvas in some ways.
But generally, I think what you're saying is it's data related to the human dynamics at the scale of a building or a state or a city or a community that is missing, and that is probably the hardest type of data to get.
That's the new and most interesting, and there's some innovations that are happening now, but you're totally right.
Yeah, and I'll build off that is, I would, in most scenarios, right, and you look at the build, and we'll get into, I'm sure, kind of the existing building stock and kind of what's being built today, let's say. If most buildings that have looked at and at least taken any action whatsoever to what we're kind of talking about, we're not talking about full kind of smart building, but we're just talking about key elements. Most of the time, there's enough data there. It's just a matter of starting to collect it, consolidate it, collate it, and Ben mentioned earlier kind of these ideas of insights, right? And I too love like that spider graph. I mean, if we could just take all the data and information that Ben knows from their technology, what we know from what's going on inside the building, and all these elements, if we could just somehow take it and make it look that simple, that quickly, that simple, we'd be much farther along than where we are. So I wouldn't say it's necessarily a particular data that we want that we don't have. As you move and you go look at the existing building stock, where I think a huge focus will be and needs to be for these types of conversations, is how do we sustainably, effectively, cost effectively implement some of these technologies in the built environment, in the existing building infrastructure, to easily deploy to get this type of data. We certainly don't want to recommend, a full rip and replace of an entire floor or a space. We want to be able very quickly, very easily get this data and information, and then show the insights to the building operator, the head of real estate, the head of nursing, let's say, or the head of clinical for hospitals. The data is there. It can be easily achieved. It's just a matter of collecting it, consolidating it, collating it, and giving it into an actionable insight, as Ben mentioned, to the right people.
Yeah. Let me ask you about digital twins. I see that cropping up in presentations from industry. My colleagues at Autodesk talk about digital twins. What are these and why are they important? Maybe start with Ben.
Sure. So Autodesk is really focused on this concept called building information modeling, and that is all about imagine a 3D model inside your computer that represents the building, how it will ultimately look once it's made. And that has been really focused on designing and then using that for constructing it. If you extend that same logic into the operations of the building, where you have that kind of twin of the real world in the computer, then you can use this 3D representation to understand first, see how is my building performing in a much more intuitive way. Instead of looking at long spreadsheets or building management systems that are hard to interpret, you could take this data and represent the most important, most useful ones in a 3D environment that is similar to how we interact with every day. But the really interesting thing about this is you take all of that data that came from upstream, from the design, from the make, to further empower your knowledge about the building, enhancing, you know, the knowledge that you have about it, whether it's a specific boiler or a piece of equipment or how a building should be performing. And then you could use that technology to simulate and start forecasting how is the building going to operate based on the data that it's collecting from the real world. So,
what is the role of artificial intelligence and machine learning in the twin system?
So I think there's two, well, maybe three big pieces. The first is simplifying all that data. So making sense of it and giving you what it thinks is most useful for you in a given moment. The second is there's a lot of simulation in these tools, and some of it can be very computationally intensive. Machine learning can make a lot of these insights instant. So it drastically increases our capability to deliver more complex insights faster. And when you combine those two things together, artificial intelligence can start to deliver, instead of here's what could happen if this one thing happened. So like give it a scenario, simulate, try again and simulate multiple times. Artificial intelligence can do all that simulation for you and actually recommend the ideal pathway for you to take depending on what your goal is. So we have this one capability called insight analysis, which you push a button, it takes all of the different possible futures about your building, runs simulations on all of them, and then nudges you in different directions depending on what your goals are, whether it is reducing, say, the energy, operational energy loads and the emissions from that, or if it's improving occupant comfort or improving daylighting, and giving you the specific recommendations of retrofit this thing here.
So ultimately you get to a kind of generative system.
Exactly. And so generative design is, and really generative operations is going to be the future of this industry, and is going to change how we interact with these technologies. So rather than drawing and pushing lines and trying to understand their impacts, we feed our goals and our constraints into the computer, and then it recommends courses of action that we can take.
So Andrew, is your company thinking about digital twins, AI, machine learning, et cetera?
Yeah, absolutely. So again, you know, a lot of times I like to kind of boil things down and make them simple. And for us, digital twin, again, means a lot of different things to different people, but it's really just a digital representation of the physical world, right? And in the physical world, in this case, and what we're talking about is the building. So whether the building is already built or is about to be built, right? It is a digital representation of what that is. And then you start talking about these insights, right? And the data and the information, whether that's live data, historical data, or predicted or simulated data, right? You start to pull all of this together, and to Ben's point, right? The machine learning and artificial intelligence is really we'll call it the smartness behind the twin. So if you were to imagine taking all this data and information and presenting it in front of a building operator, they have to start taking action on it, right? That we already struggle as an industry with the building operation and maintenance and facilities, them operating the building, keeping it up and running, keeping it safe, keeping it healthy. Imagine if there was all these other complex and more data and information. We need to make their life more simple, and start to make some of these decisions and kind of help them look through this data and information. Like, as an example, we use machine learning, artificial intelligence to find out root cause analysis. We look at an entire, let's say, system end to end. And if we start to notice kind of trends, we're not just saying, hey, there's a fault here or an alarm here. The system behind the scenes is looking at, all right, what is really the root cause of this? It may not just be this particular device or this piece of mechanical. Maybe that's being caused because of this, because of this, because of that. So the alarm or the notification that maintenance gets is the root cause that will fix all these other potential alarms and issues. That's where the industry is going, and that's what we're really excited about.
So let me ask both of you, if we were to step back and think about the best way to address climate change with respect to buildings, what should we prioritize? A retrofit of existing buildings, or the design and engineering of newer high performance buildings?
It's a great question. I mean, I would say it has to be both, right? For what we do, you know, it has to be both. We have to have a heavy focus. But if you
Well, no, but you're forced to pick because you have limited resources.
yeah, you're forced to pay. It has to be. This is my personal opinion. It has to be the existing buildings.
Okay.
That's my personal opinion. There is a lot more existing building and infrastructure. I've done a lot of walkthroughs. I've worked in the field. I've been in a lot of buildings that we see a lot of things that just would, you know, really make your head spin as far as how they're operating on a day-to-day basis. I think if we were to really focus all of our efforts that have been very much focused in the new construction market into the existing buildings, apply some of these data analytics, some of these technologies, some of these innovations, it would be incredible the impact we could make.
So Ben, I'm wondering if you agree, and let me add to it,
Sure.
because I think we're all realizing that work is changing. The nature of work is changing profoundly. Where we end up, we don't know, but it'll probably be some sort of hybrid model, working from home, coming into the office for more specialized uses and collaboration, satellite offices. There's bound to be a lot of underutilized space in central cities, in which companies go through that, and including, you know, adopt AI systems.
Yeah.
So Ben, where does all that, how does that inform what we focus on? And do you agree we should focus on retrofit?
So I'll just say that there are a lot of,
as architects, we love new buildings.
exactly, right? And I'll just say there are a lot of different signals that are coming up right now. And a year ago, we were talking about the importance at all costs of density and densification, talking about the new global cities that are popping up overnight in some countries, and how those mega cities are going to be in unlikely places like Southeast Asia and in Africa. And you can't ignore the growing population and the growing cities and the leapfrogging that they're doing over, frankly, the West in the practices that they're deploying in some of these places. And we have to be realistic about that. And when COVID is said and done, you know, progress marches on, right? As an environmentalist, and with my bias being based in California, you know, we do have a tremendous amount of underperforming building stock. And I completely agree with Andrew that we need to translate this enthusiasm and these lessons from new build and new design into what we already have built, because it's not just the operational energy, it's the embodied energy and carbon and all the materials. And there's a lot of financial value locked up in our current built environment, but there's also a lot of CO2 locked up in there. And I think the answer is probably, and this is cheating, but it's a bit of a hybrid where we need to think about how to use old building stock in new ways. And that's going to require taking some of the lessons from, you know, modular design and some of the flexibility that we talked about there, and seeing if we can deploy that to older buildings. This building that I'm not actually in, but is my background, was built at the turn of the century, 1900. But we're adapting it to perform as if it was a brand new building. And we need to think about both opportunities.
Yeah.
So there's a question related to LEED building ratings and this recognition that a platinum LEED building, for example, quite often doesn't meet expectations. And one of my frustrations is that there's not really, I think, a rational way of measuring energy performance of buildings. For example, do you measure it per square foot or per occupant? I mean, I think the only way to do it is per occupant. If you have a LEED platinum building that is largely empty, I mean, that's not. But what do you guys think more generally? How do you actually measure in a rational way the energy performance of a building?
Yeah, you know, Ken, it's a great, you know, question. I would say, you know, going back to the previous one, I think some of the early adopters, even with the existing building stock, some of the earlier adopters of some of this technology are so much better well positioned to understand what they have today and what has gone on in the last 10 months, what will happen over the next few months, and as they move into the future. But as it relates to measuring performance, yeah, I agree. I think this idea of per square foot is great, but if the building, to your point, is empty, what's really the point? And I think we have the data. We know how many people are in the building. We know how many people are on a floor in a space. Why can't we measure performance of the building per actual occupant, right? And let's say we're going to continue to stay in this flexible space. Are there technologies out there that can start to say, all right, like like you would have, all right, if we're going to start coming into the building and I'm going to be able to select where I'm going to work, let's, I guess, guide people to be selecting the floors. You don't have 5 people on one floor, 10 people on another, 20 on another. If it's flexible, let's try to guide all the people to the same floor and take those other floors that maybe we don't need today. And maybe we know that real time, maybe because we know that from historical data, and really kind of set those back and really take the performance of the building to a much, much higher level. I think that's the intelligence. Again, it's there. It's just a matter of industry being aware of it, and owners embracing it and understanding it and trying to put together a roadmap and realize, I don't need to do this overnight. This is a journey. This is something that I can start with very simply, something today that I need to try to get to in a year, 2 years, 5 years, whatever your journey is, and start to build that roadmap. Because if you don't build a roadmap, you don't know where you're going and you don't know if you ever get there.
Yeah. I think on the measurement side, I would even suggest, like, what other unlikely data sets could we bring in, and put that as the denominator in our UI calculation? Occupant comfort, productivity, happiness.
Wouldn't it be great to measure energy efficiency by the number of productive hours that the occupants engaged in?
Sure, and that's hard to measure, but I've seen it done. And these systems that are out there are flexible enough to, if you have the wherewithal to measure it, then you can bring that in and start to predict it. And I think it comes down to what the goal is for that building, what the goal is for those occupants inside of it, and really trying to connect the program and the performance of that program with those goals, instead of just the kind of standard square footage measurement that I think we've grown accustomed to over the last decade.
So we have another question. Always comes up because it's always an important question to address, and that's related to data privacy. And we live in a world where tremendous amounts of data is collected by corporations who use that data in a way that we're neither aware of nor benefit directly from, and something we have to deal with as a society. And the same is true in an office. I mean, if you have systems that are aware of movement and activity, even productivity, who controls that data, and who owns it? How does the individual that generates the data retain some kind of control over it? How can we avoid locking down the privacy system so tightly that it can't be used for the public good? I mean, these are very complicated questions.
Definitely. And I think trust for our companies is the most important thing we could be focusing on, because if data is lost, if it's stolen, if it's compromised, if it's inaccurate, if it's not able to move from software package to software package, vendor to vendor, we're just like companies that lock that stuff down in the wrong ways, or don't lock it down in the wrong ways, are going to feel some pretty big responses from their customers. I think the other interesting thing is about who is the customer here and what is the product. And if you look at a lot of tech, there's some really unfortunate answers there. And I think one thing that I'm appreciative in this industry is the people are the customers at the end of the day, and the product are the softwares and the simulation that is delivered to them, and their data isn't being used to monetize other revenue opportunities. I will say that's going to be tested more in the future as AI machine learning opportunities really start to become apparent. For instance, we have some customers who volunteered their data to power some AI that can deliver recommendations around safety on a construction site for all of industry. And they did that by opting in because they knew that as soon as they got that, by participating, they would get that capability first and that they would be able to deploy it faster and have an advantage for some time. And so I think those are the types of models that you're going to see us exploring here, and that is fueled by a lot of the consortiums and collaborations that we're all collectively a part of.
Yeah, I think the model we need to get away with is the Facebook model, where the billion users are the product. Right. They're not the customer. It's their data that's being monetized. So Andrew, do you have any thoughts on that?
Yeah, so obviously data privacy, I think we would be remiss if we start talking about these technologies and didn't think about obviously security and data privacy. So data privacy, first and foremost, to Ben's point, it's about trust, right? And if your company or let's say they start implementing, if you don't trust the type of data that they're going to collect and they're going to keep it safe and they're going to do all these things, and a company's not transparent with its employees, that's the first problem, right? If you're working for a company that says, hey, we want to do this to do X, Y, Z, and you're sitting there and like, yeah, I don't really trust that. That's obviously a problem. But I would say this idea of opting in and giving people choice is a good first step, right? And we've seen that a lot with a lot of these technologies, these workplace experience apps. The ability to opt in is a very important element. And as I think people see more value and they start to understand how it's being used and what it's being used for, and that there's a benefit to it, and a real benefit, not just, like you said, the employer benefiting it, the actual customer, the actual occupant benefiting from it. I think this will start to really pick up pace, and people will become more comfortable, more understanding of these types of technologies and what it means.
Let me ask both of you a question, maybe shifting gears back to infrastructure. So most systems in the city or in buildings are more centralized systems, top-down systems, whether it's a centralized power plant or sewage treatment plant, et cetera. In the world of computation, a lot of that is moving to the edge and much more decentralized systems. Do you see that as a possibility for the basic infrastructure in cities and buildings? And we've been exploring these concepts of without, power without grid, sanitation without sewer, water without pipes, communication without carriers, even economies without currency. We've got a list of about 40 of these that we've been looking at. But how relevant are these concepts to what you guys are thinking about?
Yeah, I think for at least us on the technology side, it's incredibly important, because I think there's a misconception that all of this data needs to push to the cloud, right? I need to collect all this data and I need to push it to the cloud. But once you start to dive in and understand what the clients are trying to do, it's like, well, you don't need the cloud to execute that. We can do that. As an example, we have this little sensor that's the size of a dime that's embedded in the light fixture that has the computing power of an iPhone that can do a lot of the things that we want to do inside the sensor, inside the light fixture. Why do we need to collect that and push it to the cloud when we've got that right there? Like I said, there's a lot of various elements of that, but I think that's kind of this idea of just understanding what the building occupant, what they're trying to do, what the value is trying to add, and let us as kind of technologists and people that do this understand and figure out, hey, where does this best make sense to kind of collect and collate and actually provide this intelligence?
Yeah, and I would just say that a building is not an island. It is affected by everything that's around it. It's interconnected. It causes impact, and it is impacted. So too with all pieces of infrastructure. And some of the more interesting things around microgrids and community scale, heat transfer and cogen. Like, there's just so much opportunity to think about the system of the city and the interconnection of all of these different nodes and how they affect each other. And I loved that projection interaction you were using, using the physical environment to visualize the data, change it, and then see what happens. And it's those types of solutions that, you know, we're going to see cities and planners using more often. And those are going to be powered by exactly the things that Andrew was talking about, where you like getting all of these nodes sharing information with each other so that then they can learn, respond, and adapt as a greater system. We're all looking at abstractions of systems here, whether it's one mechanical system in a building or the whole building or the neighborhood that is surrounding it.
So how has the pandemic changed, question for both of you, changed how you personally or your organization are approaching these problems, challenges? Start with Ben, maybe.
We're all working from home, so I'd say that's the start. I'm in my bedroom here, but I think one of the key things that we talk about is that it has accelerated the digitization of this space and has made it irreversible, because a lot of our clients, you know, they're struggling, their businesses are struggling, but a lot of them didn't shut down because they were able to keep working because they were using these digital technologies to collaborate in new ways. And, you know, we saw a lot of these global companies really thriving in the space before because, you know, the sun never set on their work. And with COVID, that's really doubly so. And I think it makes the way we work different. And I think actually it's having people build a little empathy for what we work on as well. And taking these lessons that are all very personal to us now and extending them to the customers that we're all supporting.
Yeah, and I would say for us, it's brought what we do, to kind of Ben's point, to the forefront of the conversation with leadership of these organizations, right? Before, let's say, the pandemic, we were providing these master plans and these updates to upgrade a building's technology and mechanical, electrical, and teledata infrastructure. But it really wasn't a priority outside of facilities and maintenance and management. But guess what? Now it's a much higher level of a priority in the organization. And they're starting to ask questions. Well, geez, what are we doing to provide a healthy and safety environment? What are we doing to do this? What are we doing to do that? And facilities is saying, hey, remember that kind of proposal I was put in front of you for the budget request for the last like 5 years that you said we didn't have money for? That all fed into this. So I think it's brought the conversation of what we're all trying to do within the existing building kind of built environment to the forefront of leadership of a lot of these organizations, which has been incredibly exciting, but also incredibly taxing, because now all of a sudden it was, you know, not really sure, we were not gaining a lot of, and then all of a sudden it's everybody that's saying, oh my gosh, we need to do this. We need to do it now. So like I said, it's been exciting, but it's been a lot of work, let's say. So
yeah, I think we're living in a really exciting time, and I think the pandemic has accelerated these trends that you could see beforehand, but it's just like lit a fire under the, maybe that's a bad metaphor, but it's you know, this trend towards cities without cars and you know, high performance housing and the use of computation, remote, you know, I think there will be some positive things that come out of it for sure. Anyway, thank you, Ben and Andrew. It was a pleasure. I enjoyed it.
Thank you. This is Emily here with the GABC. As a quick wrap up, a huge thank you to our panelists, Ken for the moderation, it was wonderful, Ben for getting up early there in California, kind of. And Andrew, thank you. This was all very enlightening. I definitely want to make sure that everybody knows that we are doing a series of these events, and our next one is going to be in February, on February 18th, on the circular economy for waste management with a representative from DHL and Black Forest Solutions. So please tune in for that. Registration is open on our website. Also a quick look at what's upcoming with our organization, 2 other interesting events, the German American Business Outlook, as well as a very interesting vaccine event on February 4th. If you don't know our organizations, I want to make sure you know how to reach us, the German American Business Council here in Boston, as well as the German American Business Association in California. So please do reach out, visit our websites for any other upcoming events. And with that, I will close today's event. I wish everybody a wonderful day, a good weekend, and thank you to everybody, and see you next time.